Okay, so let us start. So we've got question 7 that is from a 2017 prelim exam paper. So we have 7.1. Given f of x is equal to 1 minus 4x squared. 7.1.1, determine f prime x from first principles. So if we were to derive this normally, we would then end up with f prime of x equal to negative 8x. That is without using our first principles. That is with using the normal differentiation methods that we were taught. Exponent times coefficient, subtract 1 from the exponent, and the derivative of a constant always becomes 0. So that is it. That means that our answer needs to be negative 8x. So we are now going to use our first principles method. And if we arrive at the answer negative 8x, it means that we are correct. If we do not arrive at the answer negative 8x, that means something is incorrect. So we have question 7.1.1. We have f of x equals 1 minus 4x squared. And our formula when using first principles is f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, for those of you that do not remember the formula or struggle to remember it, you can have a look at the formula at the back of your formula sheet or at the back of your question paper on your formula sheet. So it's always going to be there for you to refer back to it. So let's have a look at our formula. The first part that we need is f of x plus h. But we have f of x from the question. So how do we turn f of x into f of x plus h? So if you notice in the bracket, you have x, whereas here in the bracket, you've got x plus h. So all you need to do is in place of x, substitute x plus h. So all you do, I'll repeat once more, wherever you have x, replace it or substitute it with x plus h. So let us do that. So we'll simplify it first and then substitute it into our formula. So we've got f of x plus h. So wherever we have x, we are going to put x plus h. And that is squared. So that's all we needed to do. Wherever we have x, we replace it with x plus h. So now we can directly substitute each component into our formula. So we're going to bring down the limit as h approaches 0 because we have not yet substituted h equal to 0. Once we substitute h equal to 0, that is the only time we will drop or not bring down the limit as h approaches 0. So we're going to substitute in place of f of x plus h, we substitute 1 minus 4 into x plus h squared minus, and then we substitute f of x, which is 1 minus 4x squared. And that is all over h. Now, all we are going to do from this step is continue to simplify this expression or continue to simplify the right-hand side such that we can get rid of the h in the denominator position. So let us continue to simplify. So we're going to bring down the limit as h approaches 0. We can now simplify. So what we're going to do is we're going to simplify x plus h all squared. When we simplify that, that is then going to become x squared plus 2xh plus h squared. All we needed to do was use our FOIL method. So we repeat the brackets twice, x plus h, and use our FOIL method, multiply and simplify. Then we end up with x squared plus 2xh plus h squared. Now let us continue. From here, we can multiply the negative into the bracket. So we're going to have negative times 1, which gives us negative 1. We're going to have negative times negative 4x squared, which gives us positive 4x squared. And that is all over h. So we bring down the limit as h approaches 0. We're going to continue to simplify. So we bring down 1. We're now going to multiply the negative 4 into the bracket. So that is going to give us negative 4 times x squared, which becomes minus 4x squared. Negative 4 times negative, or rather positive 2xh becomes minus 8xh. And negative 4 times negative h, or rather positive h squared, becomes negative 4h squared. And we bring down minus 1 plus 4x squared all over h. Now, if you notice, there's a few terms that are similar that we can use to cancel out. So we have positive 1 and negative 1. So 1 minus 1 becomes 0. So these two, we can get rid of them. Next, we have negative 4x squared and positive 4x squared. Those cancel out, and we are finally left with the limit as h approaches 0 of negative 8xh minus 4h squared all over h. So if you notice, we are now in a position whereby we can get rid of the denominator h. If we take out a common factor from our numerator, we will cancel out our denominator. So if you look at negative 8xh, our common factor is h. If you look at negative 4h squared, we can remove an h from there as well. So we're going to bring down the limit as h approaches 0, remove our common factor. So we will be left with negative 8x minus 4h all over h. From here, we can see that h cancels out h, and we will be left with the limit as h approaches 0 of negative 8x minus 4h. Now, if you notice, we no longer have a denominator of h. Previously, we had that denominator of h, whereby if we substituted h equals 0 into the right-hand side, we would have been left with an undefined answer. Why? Because you cannot divide by 0. But now, because we've got rid of the h at the bottom, we no longer have a denominator of h or a denominator of 0. We can now substitute h equals 0 into the right-hand side. So because we are now substituting, we no longer need to bring down the limit as h approaches 0. Think of it as, because you are substituting, you're getting rid of it, or you are using it up, so you cannot bring it down. So at the step whereby you substitute h equals 0, you do not bring down the limit as h approaches 0. So we substitute, so we have negative 8x minus 4, substitute h as 0. So that h becomes 0. From here, negative 4 times 0 is just 0, and we finally have negative 8. And if you remember, that is what we were supposed to get at the beginning. So we now know that our answer is correct. So that is f prime of x using our first principles. Let us move on to question 7.1.2. Now, question 7.1.2 states, hence calculate the gradient of the tangent to f at x equals 2. So we now need to calculate the gradient of the tangent of f at the point x equals 2. So to understand that question, let's do a quick rough sketch. So we've got question 7.2 or 7.1.2, and we had f of x equals 1 minus 4x squared. Now, if you look at that equation, you can see that that is a parabolic function. Why? Because you have a degree of 2, because you have x squared. Now, what type of parabolic function is it? It is a sad face parabolic function because a is less than 0, because the coefficient of x squared is negative. So let's sketch that. So we're now going to sketch a sad face parabolic function. So this is our parabolic function f. Now let us also sketch the tangent at x equals 2. So let's make x equals 2 at that point. So this is our point of contact. Now this is our tangent. And this is our point of contact. And we were told that the point of contact is x equals 2. So we need to calculate the gradient of the tangent at x equals 2. Keep in mind that the gradient of a parabolic function is not constant, it's changing. The gradient at this point is not the same as the gradient at this point, is not the same as the gradient at that point. It's constantly changing because it's a curve, whereas the gradient of the tangent is constant. So the gradient at x equals 2 will be the same gradient throughout this straight line. Why? Because a straight line has a constant gradient. So if we find the gradient of the parabolic function at x equals 2, that is the gradient of the whole tangent line. So let's ask ourselves, how do we find the gradient of a curve at a specific point? All we need to do is derive and substitute the x value at that point. So there is not a lot of steps involved. So I'll repeat it once more. In order for you to find the gradient of a curve at a specific point, all you do is derive and substitute the x value at that point. So we have f of x. So if we derive f of x, that gives us the equation of the gradient. And then if we were to substitute x equals 2, that will give us the gradient at x equals 2. So keep that in mind. We no longer need two sets of coordinates in order to find gradient. All we need is a single x value and an equation. So let us attempt that. So we have f of x, which is equal to 1 minus 4x squared. If we were to derive this, we've already derived it in the previous question, and we ended up with negative 8x. Now this negative 8x represents the equation of the gradient. So you can use this equation at any x value. If you want to find the equation, or if you want to find the gradient of the parabolic function at x equals negative 10, negative 2, negative 1, 0, 1, 10, 20, whatever, you use that equation, substitute the x value, and you'll get the different gradients at each point. But please don't memorize this. It's not a constant for every parabolic function. It is unique to that specific parabolic function. What is a constant is that if you derive the function, you'll end up with the equation of the gradient. So you can remember that as opposed to memorizing this equation. So remember that if you derive the curve equation, you end up with the equation of the gradient. Now from here, because we want to find the gradient at x equals 2, we're now going to substitute 2, and that is then going to give us negative 16. So the equation, or rather the value of our gradient of our tangent, is negative 16. So that is it. All we needed to do was derive, substitute the x value at that point, and it gave us the gradient of the curve at x equals 2 and the gradient of the tangent. So next we have question 7.2. Now question 7.2, 7.2.1. Determine dy dx if y is equal to 2 minus x all squared. So we now need to derive this equation of y, or we need to find dy dx. So it's basically something similar to what we've previously done. Your first question of calculus is always just differential calculus, so just derive. They'll give you different notations or different methods that you can use, but it's basically the exact same thing, to just derive. So let us now derive y equals 2 minus x all squared. So this is question 7.2.1. We have y equals 2 minus x all squared. Let us confirm if that's correct. Yes, it is 2 minus x. Now, if you look at this, we cannot derive just yet. This is not in a form that is derivable. We need to first simplify it. Once we simplify it, then can we derive. So don't ever derive the equation if it is in this form. Always simplify by expanding the brackets and then derive. So we are not going to introduce dy dx just yet. We are first going to simplify. At the step whereby we derive, that is when we introduce dy dx. So if we were to simplify this, because it's squared, we repeat our brackets twice. From here, we can now use our FOIL method to simplify. So we're going to have 2 times 2. We'll have 2 times negative x times 2, and negative x times x squared. That gives us 4 minus 4x plus x squared. Now it is in a form that we can derive. So this is when we introduce dy dx. So we put in dy dx equals, now our rules when deriving, if we have a constant, which is our first term, positive 4 is a constant. If you derive a constant, it becomes 0. So this is then going to be 0. That 4 becomes 0. Next, let's have a look at negative 4x. So we need to derive negative 4x. Negative 4x just becomes minus 4. If you remember during last week's session, we explained the shortcut process. So I'll repeat it once more for those that did not attend last week's session. So the rule when deriving, let us derive minus 4x. The rule when deriving is to multiply your exponent times your coefficient. Now your exponent is positive 1. So exponent, which is 1, times your coefficient, which is negative 4. Keep in mind a coefficient is the numerical value or the variable, whatever it is, as long as it's in front of your variable. So if you have ax and you are deriving with respect to x, that means the coefficient will be a. But if you have xa and you are deriving with respect to a, that means your coefficient will be x. Basically, your coefficient is the value or the number or variable that is in front of what you are deriving with respect to. So if we look at this, our coefficient is negative 4. So we are now going to multiply 1 times negative 4, which will give us negative 4. Next, we subtract 1 from the exponent. We are not subtracting 1 because the exponent is 1. It does not matter what value the exponent was. It could have been 10, 20, y, z, it doesn't matter. Whatever the value of the exponent is, it does not matter. You always subtract 1. That is the rule. So we have x to the power 1 minus 1. From here, this becomes negative 4x to the power 0. And we know that anything to the power 0 is 1. But keep in mind, the negative 4 is not raised to the power 0. It's only the x that is raised to the power of 0. So this becomes minus 4 times 1. That x to the power 0 became 1. Negative 4 times 1 just becomes minus 4. But a shortcut, if you want to remember this, is that if your variable has an exponent of 1 and you want to derive this term, all you need to do when deriving is to take the coefficient of your variable. Please just give me a second. Okay, so I'll repeat that once more. When you are deriving and your variable has an exponent of 1, a shortcut is to just write down the coefficient. So if you derive something that has an exponent of 1, the answer of the solution is just the coefficient. That is how we ended up with negative 4. So we derive a constant, which is 4, we get 0. When we derive negative 4x, we ended up with negative 4. Now we need to look at the third term, which is x squared. We now need to derive x squared. So we're going to multiply the exponent, which is 2, times the coefficient, which is positive 1. That gives us positive 2. Next, we need to subtract 1 from the exponent. So 2 minus 1 just gives us 1. And we are then just left with 2x after deriving x squared. So we can conclude dy dx is equal to 2x minus 4. And that is our solution. So we've got question 7.2.2. F of x is equal to, or rather, determine f prime of x if f of x is equal to the cube root of x squared plus 1 over 4x to the power 4. So if you look at this, straight away you can see that the first term is not in a form that we can derive. The second term is also not in a form that we can derive. We first need to change them or simplify them such that we can now derive. So an important rule to remember, if you have a surd, or if your variable that you are deriving with respect to is underneath a surd is a root sign, whether it's the square root, cube root, fourth root, fifth root, sixth root, it does not matter. That is called a surd, as long as you have a root sign. So if your variable that you are deriving with respect to is underneath a surd, you cannot derive. You need to change the form before you can derive. Then if you look at the second term, our variable that we are deriving with respect to is a denominator. So because it is a denominator, we cannot derive as yet. So let's go through that again. If it is a surd, you cannot derive yet. You have to change the form. If your variable is a denominator, and let's just put in brackets single denominator, you cannot derive just yet. If it has multiple terms, so if it's a denominator with multiple terms, that becomes slightly more complicated. So when it is a single denominator, all we need to do is move x to the power 4 to the top. But if it has multiple denominators, we cannot just move it to the top. So to explain the difference between a single and multiple denominator, let us take a step back and revisit the question we did last week, or actually the week prior to last week. That had a double denominator, if I'm not mistaken. Let's have a look. And not this one. Here it is. So if you look at this question, let's compare what we have today and what we did 2 weeks ago. So if you look at question 8.2.2, you can see that there's multiple denominators. You've got multiple terms in your denominator section. Whereas in today's question, we have 1/4x to the power 4. So if you look at this, what's the difference? If you look on the right, we've only got a single x or a single term in the denominator. Whereas if you look on the left, we've got x and we have -4. So there's more than one term. So when we're dealing with the scenario on the right, 1/4x to the power 4, all we need to do is move the variable to the numerator. So it then becomes 1/4x to the power -4. Always remember, when you move something from the top to the bottom or the bottom to the top, the sign of the exponent changes. If you look at this, we've got 4x to the power -4. We are only moving x to the power 4. The exponent is positive at the bottom, so when we move it to the top, it becomes negative. But if you look at the scenario on the left, you cannot move x -4 to the top. If you were to move this to the top, because you can't just move x and leave the 4, -4, it doesn't work like that. If you were to move it, you'd have to move the entire denominator. So you'd move it and it would become x -4 to the power -1. But what do you do then? You're stuck. Because if you were doing caps, if you're doing the cap syllabus, you don't know how to solve for this yet. If you are doing IEB, then you can use your chain rule and your product rule to derive and you'll work it out. But because you are doing caps, you cannot use that method. So this would be wrong. You have to simplify the top such that it cancels out with the denominator. As we've done here, if you notice, we simplified such that that denominator canceled out. So those are the rules. If you have a surd, you cannot derive as yet. You need to change the form of that surd. If you have a single term in your denominator area, that is the variable that you are deriving with respect to, you can move that variable to the top by changing the sign of its exponent. If you have multiple terms in your denominator, whereby one of those terms is the variable that you are deriving with respect to, then you need to simplify the numerator such that it gets rid of the denominator. You need to cancel out the denominator. So keep that in mind before deriving. So let's have a look at question 7.2.2. So we've got f of x is equal to the cube root of x squared plus 1/4 x to the power 4. Now from here, we need to first change the form before we can derive. Why? Because we cannot derive if we have a surd, nor can we derive if our variable is a denominator. So we are not introducing f prime x because we are not deriving as yet. Now we need to change the surd. So let's do a random example. If this is our surd and we have x to the power 2, this is what we are dealing with. Whenever you change the form of your surd, all you need to do is repeat what is under the surd. So repeat x squared. And then divide your exponent by the sign of the surd. So because we have a 3, we're going to divide by 3. If we were dealing with the square root of x to the power 3, for example, so we're dealing with the square root of x cubed, all we would do is repeat what is under the surd and divide by the sign. Keep in mind, square root has an invisible 2. So you would divide by 2. Let's say, for example, we are trying to find the fourth root of x to the power 8. Once again, repeat what is under the sign and then divide by the sign of the surd. So that will then become x squared. That is it. Repeat what is under the surd and then divide by the sign or the number on the surd. So let us do or simplify the first term. So the cube root of x squared becomes x to the power 2 over 3 plus. Now, in the second term, we're going to move x to the power 4 only. We are not moving 4 to the top. We are only moving x to the power 4. So we repeat 1 over 4. It stays as is, nothing moved, except x to the power 4 becomes x to the power negative 4 in the numerator section. Now it is in a form that we can derive, so we introduce f prime x. Now, same rules as before. We're going to multiply the exponent, which is 2 over 3, times the coefficient, which is 1, and that gives us 2 over 3. Next, we subtract 1 from the exponent, and that is then going to give us 2 over 3 x to the power negative 1 over 3. So we've now derived the first term. We're not done as yet. We still need to derive the second term. So I'll repeat once more. Once we've derived the cube root of x squared, we end up with 2 over 3 x to the power negative 1 over 3. Let's look at our second term. Now, second term is 1 over 4 x to the power negative 4. So just as before, we're going to multiply our exponent, which is negative 4, times the coefficient, which is 1 over 4. So positive 1 over 4 times negative 4 becomes negative 1. So if you want to do it the long way, 1 over 4 times negative 4, 4 cancels 4, positive 1 times negative becomes negative 1. Or you can just put it on your calculator, negative 4 times positive 1 over 4. So we end up with negative 1. Next, we need to subtract 1 from the exponent. So we have x to the power negative 4 minus 1, which then becomes minus x to the power negative 5. Now, if the question specified that we need to leave our answer in a positive exponent form, then we would have to move x to the power negative 5 to the bottom into the denominator position, which would then become 1 over x to the power 5. If we, or specifically negative 1 over x to the power 5. If we had to do the same thing with the first term, it would become 2 over 3x to the power 1 over 3. We can even further change it to 2 over 3, the cube root of x. So that is how you can change it if the question specifies that you need to convert it back to a surd form, or if you need to leave it as positive exponents. But if the question does not state that, then you can leave it where we last stopped. You do not need to convert it to positive exponents unless otherwise stated. So that is question 7.1. 0.2, 0.2. So our next question is our calculus graphs, our cubic functions. So let us proceed. Question 8. So given f of x is equal to x cubed plus bx squared plus cx plus d, and g of x is equal to 2x. So something important to take note of. For those of you that were in the last session of calculus, this is quite a similar question to what we previously did. If you remember in the previous question, we were also given the coefficient of x cubed and asked to find the remaining variables. So if you notice, the questions are quite similar. If you go through past paper questions and you understand what's going on and you understand the process, you will not get it wrong in the exams. So my advice is go through as many past paper questions as you can. As you're going through the past paper questions, you'll notice the questions just repeat themselves. They're asking you the exact same thing over and over. They just change the values. So we've got x cubed. The coefficient of x cubed is 1. So this is technically 1x cubed. Okay. Now, let us continue. The graph of f intersects the x-axis at -2, +1, and 3. So these 3 points that I'm going to highlight are your x-intercepts. X-intercepts are quite important when you are trying to find the equation of a function. So these are your x-intercepts. Now, if we continue, it states the turning points of f are the points A and B respectively, where the x value of B is greater than the x value of A. So what that means is that the x value of B is bigger than the x value of A. As you can see, B is in the positive area, whereas A is in the negative x area, which means, or not means, but you can see where the statement comes from. X of B greater than x of A. As you can see, B is positive, A is negative. So that means what? A positive will always be bigger than a negative. We know that already, right? So another thing that you can notice is that A is a maximum because it's higher than B, whereas B would be a local minimum. Okay. So whatever y values we find, if we are asked to find the turning points, the bigger y value will be for A and the smaller y value will be for B. So x of B is greater than x of A, but y of A will be bigger than y of B. So let's just make a note of that. So y of A is greater than y of B. Why? Because A is higher than B. Now, if we continue, we've got line PQ is perpendicular to the x-axis. So it means that there's an angle of 90 degrees between PQ and the x-axis. In addition to that, it means that PQ is parallel to the y-axis. It means that PQ is a perfectly vertical line. Why? Because the y-axis is perpendicular to the x-axis and PQ is perpendicular to the x-axis. So it means that P is parallel to the y-axis, or PQ is parallel to the y-axis. Another reason is, as you can see, these are corresponding angles. Why? Because there's an F shape. Okay. So it means that PQ is perfectly vertical. Now, question 8.1, show that the equation of f can be given as f of x is equal to x cubed minus 2x squared minus 5x plus 6. So we basically need to find the equation of f whereby b is equal to -2, c is equal to -5, and d is 6. So there were there were two methods that we discussed in the previous class. I'm going to use one of those methods, but keep in mind the two that were previously discussed are not the only two methods. Those of you who did not attend the previous class, there is a recording of it. You can view that recording. Now, back to what we were saying. There is not only two methods that you can use to find the equation of a cubic function. There's multiple methods that you can use. I would recommend knowing all the different methods. If you want to use all the different methods or practice the different methods, I would recommend looking at November or final past papers. Final papers usually have the different methods. I think if you go back to from 2015 to 2022, there's a different method used in each question paper to find the equation of the cubic function. So I would recommend having a look at that. You can use your turning point and your x-intercept. You can use all three x-intercepts. You can use both turning points. You can use your comparison method. You can use your point of inflection method. So there's multiple different methods that you can use. You can also use your derivative method as well, but that will mostly lead you to your comparison method. In addition to that, you can also use a simultaneous equation method using gradient or turning points. But yeah, there's multiple methods that you can use. I would recommend having a look at November past papers, and that'll make it easier for you to gain practical experience by using all different methods. So let's start. We need to find the equation of f. That is question 8.1. So for question 8.1, I'm going to make use of this method, my x-intercept method. To use my x-intercept method, I need to use this formula. The only reason that I can use this formula is because the cubic function has 3 x-intercepts. So if you look here, we were told that we've got x-intercepts, x equals -2, x equals 1, and x equals 3. Because we have all 3 x-intercepts, I can now substitute those values into x1, 2, and 3. In addition to that, I have my value of a. So keep this in mind. Let's make a small note before we proceed. So when you look back at it, you can understand what is what. Why is it not moving? So this represents the coefficient of x cubed. Then x1, 2, and 3 represent the x-intercepts. So always remember that a represents the coefficient of x cubed. x1, 2, and 3 represent your x-intercepts. So if we go back to our function or the very first statement, given f of x is equal to 1x cubed, we now have the value of a because the coefficient of x cubed is 1. So we can now substitute a equals 1. So this is going to be y equals 1 times x. Let us have a look at x1, 2, and 3. What are their values? So if you have a look, we've got x equals -2, 1, and 3. Those are our 3 x-intercepts. So let us now go and substitute that. So we've got x minus -2, x minus 1, and x minus 3. Let's just confirm if that's correct. It's 1, 3, -2. Yes, that is correct. Now, all we need to do from this point is simplify. Negative times negative becomes x plus 2. x minus 1, x minus 3. So these are our three x-intercepts and our value of a once they've been substituted into the formula. Next, we need to simplify. So I'm going to bring down x plus 2, and then I'm going to use my FOIL method on x minus 1, x minus 3. So x times x gives me x squared. X times negative 3 gives me negative 3x. X times, or rather negative 1 times x gives me negative x minus 3. From here, because we've not simplified the second bracket fully, we can bring down x plus 2 and continue to simplify it. The like terms are negative 3 and negative 1. So minus 3x minus x becomes minus 4x minus 3. Now that we've simplified the second bracket as far as possible, we can now multiply the first bracket with the second bracket. So when we multiply, we're going to have x times x squared, x times negative 4x, and x times negative 3. Yes, I did see there was a question pop up in the chats. Please give me a moment to finish this up, then I will attend to it. So let's start there. We'll multiply that first, then we'll multiply 2. So x times x gives us x cubed. X times negative 4x gives us minus 4x squared. X times negative 3 gives us negative 3x. Now let us multiply positive 2 times the second bracket. So that'll be positive 2 times x squared, positive 2 times negative 4x, and positive 2 times negative 3. So that's going to give us positive 2x squared minus 8x minus 6. Now, from here, let us continue. One mistake, though, that I've noticed, that is supposed to be positive 3. Sorry about that. This is going to be positive. This negative 1 times negative 3 gives us positive 3, not negative 3. So this will be positive 3 and positive 6. Sorry about that. X times, oh yes, it was the mistake from previously, that from the previous step that got carried over. This was supposed to be positive, which means negative 8 and positive 3 gives us positive, or rather negative 5. So that one mistake from the sign created so many problems. Okay, so let's just repeat once more. So because we have all three x-intercepts, we can now use our y equals a into x minus x1, x minus x2, x minus x3 method. In order for you to use that method, you need the coefficient of x cubed and you need all three x-intercepts. If you do not have the coefficient of x cubed, an alternative method would be to have a random coordinate. If you have a random coordinate that is on the cubic function, you can substitute that random coordinate into y and x in order to find the value of a. Once you find the value of a, that is when you substitute a, x1, x2, and x3. Once you've substituted those four values, all you then need to do is simplify the right-hand side until you end up with your function. So as you can see, we have x cubed minus 2x squared minus 5x plus 6, which is what the question has. So we know our answer is correct. So before we proceed, just give me a second to go back to the chats. Okay, Bong, we got the value of a from the question. So just give me a moment. I will zoom in for you. So the student that asked the question in the chats, our value of a is over here. Keep in mind that whenever we write a variable, if the coefficient is 1, we just usually write it as x. or x cubed. We don't really write 1x cubed. So always remember that if you don't see a coefficient in front of your variable, it means there's an invisible 1 there. So always remember that, it's important. Same thing is true for your exponents. If you look at g of x, there's an invisible 1 here. This is technically 2x to the power 1. But when we have a coefficient or exponent of 1, we just leave it out. So yeah, the student that asked that question, the value of a was obtained from the question. We were given that a is equal to 1. Why? Because a is the value of the coefficient of x cubed. Then, okay, then that one was attended to. Yes, Tisetso, you can use the FOIL method in the first 2 brackets. So I just chose to do the second or the last 2 brackets and then multiplied with the first bracket. You can do FOIL method on bracket 1 and 2 and multiply 3 with the big one. It doesn't matter. I just prefer to do the last 2 and then the first one, because I prefer to make my arrows go forward as opposed to going backwards. It's just a personal thing. If you want to do the other way, it's completely up to you. It honestly doesn't matter which way you do it, you'll end up with the same answer. Question 8.2 states, calculate the coordinates of A and B. So if you have a look, what do A and B represent? We were told from statement or point 2 that the turning points of F are the points A and B respectively. So we now know that A and B represent turning points, or you can call them stationary points. So how do we find the coordinates, or how do we find those stationary points in calculus? Always remember that if you want to find the turning point or stationary points in calculus, you derive once, equate to 0, solve for x. So there's only 3 steps involved. Derive once, equate to 0, solve for x. That's the process. So let us attempt question 8.2. So we need to find the stationary points A and B. So 8.2, our function is f of x equals x cubed minus 2x squared minus 5x plus 6. So this is our function, right? Now we need to find the stationary points of this particular function, which are labeled A and B. So just give me a second to double check. Minus 2, minus 5, yeah, my function is correct. So let us proceed. So step number 1, we need to derive. So f prime of x will then give us 3x squared minus 4x minus 5. So that is the first derivative of f. From here, we need to equate this equation to 0. Why do we equate the right-hand side to 0? Why do we say that the derivative is equal to 0? The reason is because of the gradient at those points. So let us draw a cubic function. Now, let's just have a look at this maximum. If you draw a tangent at the maximum, let's draw a horizontal tangent. The gradient at this maximum is 0. And what is another way of representing gradient? It's f prime of x. We discussed that in question 7, right? So another way of representing gradient is f prime x. So the reason that we equate this to 0 is because we are not technically equating but substituting as 0, because the gradient at the stationary points is 0. This f prime of x is 0. So technically we're just substituting f prime of x as 0. So that's all we're going to do. So we have 3x squared minus 4x minus 5 equals 0. From here, you can use your, what do you call this thing? Your quadratic formula, or you can factorize, it doesn't matter. If you see that factorization is not working out, it's most likely because the values of x are decimals. So you'd have to use your quadratic formula. So if we use our quadratic formula, keep in mind your quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So if you substitute your value of a, which is 3, your value of b, which is negative 4, and your value of c, which is negative 5, into your quadratic equation, you will end up with x equals 2,12 or x equals negative 0,79. Those are your two x values. Now, if we go back to our graph, we can see that b is in the positive x area and a is in the negative x area. So the positive value will be b and the negative value will be a. So that means that our value 2.12 is b and our value negative 0.79 is our value a. So this will be xb and xa. From here, if you want to find the y values of your stationary points, all you need to do is substitute the value of x back into the original function. Do not substitute it into the derivative. If you substitute it into the derivative, you are going to get the gradient at those points. So you need to substitute it back into the original. So you're going to substitute it into f of x. Once you substitute 2.12 into f of x, you will end up with negative 4.06. So our coordinate of b is 2,12 and our y value is negative 4,06. That is our coordinate of b. Once you substitute x of a, or negative 0.79, into f, you will end up with negative 0.79 and a y value of 8,21. So those are your coordinates of a and b. So I'll repeat once more. If you need to find your stationary points or your turning points, all you need to do is derive, equate it to 0, solve for x. If you want to find the y values, always substitute them back into the original function. So that is question 8.2. Next, we have question 8.3. Now, question 8.3 is for the most marks. It's a 6-mark question. So we have 8.3. Calculate the maximum length of the line PQ. So let's go back. There's PQ. It's that vertical line that we discussed earlier. So let's highlight it. This is PQ. So it says calculate the maximum length of the line PQ. Now, what is important about this statement or about this question is this word over here, maximum. Now, what does maximum mean? What do we refer to as a maximum? Is it not one of our stationary points or the highest stationary point? So when the question states calculate the maximum of something, all you are doing is calculating the turning point, the highest turning point of that particular line or function or curve or whatever it is. So keep that in mind. Whenever the question states calculate the maximum or the minimum of something, all you are doing is calculating the turning point of it. You'll see that used quite frequently when you do optimization. The use of maximum and minimum is frequently used within optimization, which we'll have a look at tomorrow. So let us have a look at this. We need to calculate the maximum length of line PQ for the interval -2 until 3. So if you notice within that area from -2 until 3, we need to find the maximum length of PQ. So before we can even start finding maximum, we need to first get the equation of PQ, because how can you find a maximum or a turning point if you don't have an equation? So let us first find the equation PQ. So how do we find the equation of a vertical line? Let's do a quick example. Now, if we have this vertical line, let's say this has a y value of 10, and this part has a y value of 2. So this is our vertical line. Let's give it the same name, PQ. So we're only using this as an example. It's not the answer, it's an example. So if we want to find the equation of this, all you do, or if you want to find the height, because technically finding the equation of a vertical line is the same as finding the height of that vertical line. So we have PQ. If we want to find the equation or the height of this line, all you do is say top minus bottom. So we're going to have 10 minus 2, that gives us 8. So we now know that the length of PQ is 8, or the equation of PQ is 8. Because if you say y equals 8 or distance equals 8, technically these are equations, are they not? They have a left-hand side, an equal sign, and a right-hand side. So if we want to find the equation of a vertical line, just from this example, we take the highest point minus the lowest point. So let us go back to our function. Before we do, just give me a second to attend to the question that was raised in the chats. Someone said, can't you factorize 3x squared minus 4x minus 5 as 3x minus 5, x plus 1? Okay, give me a second. 3x minus 5, x plus 1. Okay, so if you want to find out if your factorization technique is correct, or if you want to find out if you've correctly factorized, all you need to do is expand. So 3x minus 5, x plus 1. Just give me a second to see if I've correctly copied that. 3x minus 5 and x plus 1. Yeah. So multiply 3x times x, that gives you 3x squared. 3x times 1, that'll give you positive 3x. Negative 5 times x, that'll give you minus 5x. And minus 5 times 1 gives you negative 5. If you add up the two middle terms, that gives you 3x squared minus 2x minus 5. If we go back to, where was it? If we go back there, let's see, what did we have? We had 3x squared minus 4 minus 5. So if you notice, that middle term is incorrect. That means we cannot factorize it using 3x minus 5 or x plus 1. Okay, so always whenever factorizing, just double check by substituting it or expanding. If you are using quadratic formula, you'll substitute back into the original function and see if it gives you 0. If you're using factorization, you can also substitute and see if it gives you 0. Alternatively, you can expand and see if that expansion gives you the original again. So if you expanded, it was supposed to give us 3x squared minus 4x minus 5, okay? Let me see, that was the last one. Okay, sure. Bong, I saw you had your hand up earlier. Do you have another question or? Okay, wait, just give me a second. I see there is a question. On 8.2, okay, just give me a second, T. Let me go back to 8.2. Okay, here's 8.2. So you've stated, let's just give me a second. On 8.2, when it is stationary point or turning point, do we derive twice and equate to 0? Okay, T, so we don't derive twice. When we are finding a stationary point or a turning point, you derive once. Equate to 0, solve for x. That is it. So I'll write it on the side. This is finding a stationary point. So you derive once, equate to 0, and then solve for x. This is when you're finding a turning point or stationary point. But if you are finding a point of inflection, that is when you derive twice, then equate to 0, then solve for x. So don't mix up the two. When you find turning point, you derive once. When you find a point of inflection, you derive twice. So they are different. Keep that in mind, okay? Don't confuse the two. So yeah, so repeat once more. When you are finding a stationary point or turning point, derive once, equate to 0, solve for x. That is it. Okay, so let us go back to 8.3. So, like I mentioned earlier, all you're going to do to find the equation of a vertical line is take the highest point minus the lowest point. But because we don't know what is the y value at the highest and the lowest, so let me circle them. This is the highest. And this is our lowest. Because we don't know what the y values are at the highest and the lowest, we can't subtract them, or we can't use the actual y values to subtract them. But what do we know outside of the y values? We know that P is a point on the cubic function and Q is a point on the straight line function or the linear function. So if you do not know the values of the highest and the lowest points, all you need to do to find the equation of a vertical line is take the top function minus the bottom function. So in order for us to find the length PQ, or in order for us to find the equation PQ, we are going to take f of x minus g of x. Always remember that. Top function minus bottom function. So let us attempt question 8.3. Just give me a second to clean this up. So question 8.3. In order for us to find PQ, we need to take the top function minus the bottom function. So that is then going to be PQ equals f of x minus g of x. So f of x was x cubed minus 2x squared minus 5x plus 6 minus g of x. Let us have a look. What is g of x? G of x is 2x. So we need to subtract 2x. From here, we can get PQ as equal to x cubed minus 2x squared. Now, negative 5x and negative 2x become negative 7x plus 6. So this is now our equation of PQ. Keep in mind, how do you get the equation of a vertical line? It's the top function minus the bottom function. That is the equation. We are not done with the question as yet. Keep in mind, the reason that we tried to obtain the equation was in order for us to get the turning point. More specifically, the maximum turning point. So if we were to do a rough sketch of PQ, because if you look at the equation of PQ, it's in a cubic form, right? Please don't get confused because you see that PQ is a vertical line, but we have a cubic function. It doesn't mean that that straight line is now a cubic function. That's not what it means. It just means that if you were to substitute the x value at that point where PQ intersects the x-axis, you would get the length of PQ. It doesn't matter what type of function is used to represent it. At the end of the day, you need to understand if you substitute the x value, you get the length PQ, okay? The only reason that it is in a cubic form function is because we used the top, which is a cubic, minus the bottom, which is a linear. That is it. So we have the equation PQ, and from this equation, we need to identify the maximum length of PQ. So take note the use of the word maximum. That refers to your stationary points or your turning points. So all we are now going to do for this particular question is to find the maximum of PQ. So how do we do that? We've previously done it already. In a way, question 8.3 is a repetition of 8.2. All we're doing is finding stationary points. So just as before, we derive once. So PQ derivative. So that is going to be 3x squared minus 2. This is supposed to be squared, sorry. So that is then going to become 4, not 2. So it's going to be minus 4x minus 7. So once we've derived PQ, we end up with 3x squared minus 2, or rather minus 4x minus 7. So that is it. What is the next step? We need to equate to 0. So let's remind ourselves about what we discussed earlier. What are the rules when finding a stationary point or turning point? We derive once, which we did. We then equate it to 0. So let's do that. So we have 3x squared minus 4x minus 7 equated to 0. And what is our third step? We need to solve for x. So when we solve for x, we are going to factorize this. So we open up two brackets. Now we need to ask ourselves, what times what gives us the coefficient of 3, or 3x squared? That is 3x and x. Next, we need to ask ourselves, what gives us the constant? So it's -7 and +1. But how do we know where to put it? Do we put -7 in the first bracket or the second bracket? Do we put +1 in the first bracket or the second bracket? To do that, you can use a simple technique on the side of your page. So just multiply 3x and x. That's the first term in each bracket. On the right side, you put your factors of your constant, which is -7 and +1. So let's put -7 over here. So -7 and +1. From here, you need to cross multiply them. So x times +1 gives us x. 3x times -7 gives us -21x. If we add this 2, it gives us -20x. If you notice, we need -4x, not -20x. So what we are now going to do is we are going to swap them. We're going to put 1 at the bottom and -7 on top. So let's see. All you need to do is try different combinations till you get the middle term. So for those of you that struggle with factorization, you can use this or any other technique that you're familiar with. If you want to get more details on this technique, there are a few videos that I've recorded on this that you can have a look at. So let's cross multiply once more. X times -7, that gives us -7x. 3x times 1, that gives us +3x. If we add up -7x and +3x, we get -4x. And as you can see, that is what we need. So all we are now going to do is bracket it as per this. So these are our brackets. So it's going to be 3x minus 7 and x plus 1. From here, x will be equal to 7 over 3. And x will be equal to -1. So we have two x values. Keep in mind that we need to find the maximum. The maximum is the one that has the bigger y value. So which one is going to give us the maximum? We need to substitute our values of x into our original equation. For those of you that are not sure, the original equation is the equation that comes just before the derivative. That is the original equation, PQ. So we need to substitute these x values into PQ, and the one that has the greater y value will be our answer. So let's do that. So if we substitute, let's start with the one on the left. So if we substitute 7/3, we will then end up with negative 8.52. And if we substitute -1, we will then end up with 10. So we ask ourselves, which is the bigger y value? Is it negative 8.52 or is it positive 10? We know that a positive will always be bigger than a negative, so we are going to use the positive 10 value. So our answer to this particular question is therefore PQ equals 10. So this is the maximum value or the maximum length of PQ. Keep in mind that if the question stated what value of x produces the maximum length of PQ, your answer would be -1. So if they specify what value of x, you write down the x value. If they specify what value, they're referring to y. So if they say what value of x, that's them being specific, you need to write down the x value. But if they don't, when they're asking for the y value, they won't state what value of y. They will just state what value gives you the maximum. That means what y value, okay? So that is it basically. That is question 8.3. Our question stated, calculate the maximum length of the line PQ for the interval -2 until 3. So all we needed to do was first find the equation of the line PQ. Why? Because we cannot find a stationary point without an equation. So we find the equation by taking the function on top minus the function at the bottom. That gave us the equation of PQ. Once we have the equation PQ, we then need to find the stationary points of PQ. In order for you to find the stationary points or turning points, you derive once, equate to 0, solve for x. Once we found our x values, we needed to identify which gives us a maximum and which gives us a minimum. We need the maximum, not the minimum. So that is why we took that value of 10, because that is the maximum length of PQ. So that is question 8.3. Rebone or Rebone, sorry about the mispronunciation. Do you want to unmute yourself and speak up?
Sir, may I ask? You said that
yes.
When calculating the turning point,
yes. Sorry, can you speak up a bit more? It's just a bit difficult to hear you.
When deriving the turning point, like when calculating the turning point, you derive once, but then when you calculate the inflection, yeah, you derive twice. You solve for x like how you do for the turning point.
Yes, that is correct. So students that did not hear the question was, what's the difference between calculating the stationary point and your point of inflection? So keep in mind the process of calculating a stationary point and your point of inflection are quite similar. There's only one difference. So when you calculate a point of inflection, you derive twice. When you calculate your stationary point, you derive once. And then equate to 0, solve for x. So the process is the same. The only difference is the number of times you derive. So when you find point of inflection, keep in mind you derive twice. When you find your stationary point, you derive once. Point of inflection 2 times, stationary point 1 time. Okay, then just give me a second. Just to clarify, do we only find the second derivative when dealing? Yes, Priyanka. So we find the second derivative when we are dealing with point of inflection. You'll see in the next question, we actually need to calculate the point of inflection. So you'll see how to calculate it there. So I'll repeat once more. When you're finding a stationary point, you derive once, equate to 0, solve for x. When you are finding a point of inflection, you derive twice. Twice meaning 2 times. So you find the second derivative, equate to 0, solve for x. If they ask you to find the maximum or the minimum of something, that is the same as asking you to find the stationary points. So keep that in mind as well. So let's have a look at question 8.4. So question 8.4, the graph of f is concave down for x less than k. So something important to take note about or to take note of regarding concave up and concave down. Concave down represents a sad face. So an easy way to identify concave down is, let's say this is our cubic function. And let's say our point of inflection is over here. This is our point of inflection. Okay, and it's x equals k. Since they've used k, I'll proceed with k. Now, all the values on the left represent concave down. All the values on the right represent concave up. So smiley face, concave up, sad face, concave down. Always remember that, okay? So let's look at concave down. So if we want to recreate that sad face area, this will be it. So as you can see, that looks like a sad face. So it's going to be x less than the value of k for concave down. If you want to find concave up, it's going to be x greater than k. So that's our point of inflection, smiley face, and that's going to be x greater than k is concave up. Okay, always remember sad face, concave down, smiley face, concave up. If you struggle with your inequality signs, meaning that you're not sure which way the inequality sign must face, always remember or always use your arrows. So in which direction, let's say the question was for what values of x is it concave down? So we can see that the smiley face is on the right and the sad face is on the left. So if we want to find concave down, that's sad face. So we need to go to the left. So you make your arrow pointing in the direction of the sad face. As you can see, my arrow is pointing left. As you can see, if you repeat the arrowhead, that's the same as the inequality sign. They look the same. So you can copy your arrowhead if you don't understand or if you struggle with remembering which sign to use. Let's say the question was find concave up. Concave up is smiley face. Smiley face is on the right. So make your arrow point right. If you look at the arrowhead, it's exactly the same as my inequality sign. So that's a small little trick that you can use if you forget your inequality signs. So let's go back to our question and see what were we supposed to calculate. Question 8.4, the graph of f is concave down for x less than k. Calculate the value or values of k. So we need to find what is the value of k. Before we can even start to calculate k, we need to ask ourselves, what does k represent? How do you calculate something if you don't know what it represents? So we can see that k represents the point of inflection. How do we know that? It is because it's used in concavity. Whenever they refer to concave up or concave down, always remember that the point of inflection is used. Why? Because your point of inflection is the point whereby the graph is neither concave up nor concave down. It's where it starts to become concave. So if you take a step to the right in this particular graph, it starts to become concave up. If you take a step to the left, it starts to become concave down. So think of it as your starting point. It's like your origin of your graph. If you move right, up. If you move down, or if you move left, it's down. So it's your starting point. That is why we refer to your point of inflection whenever we are dealing with concave up or down. So that is how we know that that K value represents your point of inflection. So we need to calculate the point of inflection. So how do we calculate a point of inflection? We derive twice, equate to 0, solve for x. But that is not the only method. So I'll use both methods so that you can see, or you can have an additional method to use. So question 8.4, we need to find our point of inflection. Now, our original function is f of x equals x cubed minus 2x squared minus 5x plus 6. So we need to derive twice. So that is then going to be f prime. That's the first derivative, is 3x squared minus 4x minus 5. So that is the first derivative. But keep in mind, we are finding point of inflection, therefore we need to derive twice. So we derive again, that is then going to be 6x minus 4. Once we derive, we then need to equate it to 0. So we've derived the second time, so now we equate to 0. After we equate to 0, we solve for x. So that is then going to give us 2 over 3. So therefore, K is equal to 2 over 3. Our point of inflection is at x equals 2 over 3. And since the point of inflection is your value of K, that means K is equal to 2 over 3. If you don't want to write it as a fraction, you can also write it as a decimal. So 2 over 3 is just 0.67. Doesn't matter which way you write it as, it's still the same thing. 2 over 3 is just 0.67. Okay, now that is method 1. That is if you have the function. But what if you don't have the function? How do you derive twice if you don't have the function? You can't, right? You need a function in order to derive twice. So what is another method that we can make use of in order to find our point of inflection without a function? So let's call this method 1. And then the second method, we'll call it method 2. So this will be method 2. Now, in order for us to use method 2, if you do not have your function, you can use your turning points, because your turning points, or rather, because your point of inflection is the midpoint of your turning points. That only works for the x values, not the y, okay? So let's sketch. Let's do a rough sketch. If this is our function, right? And this is our point of inflection, x equals k. Let's call this our minimum and our maximum. If we want to find the point of inflection without using the function, always remember that the distance from your maximum to your point of inflection is the same distance from your point of inflection to your minimum. Or another way of thinking about it is that the point of inflection is the midpoint of the x values of your stationary points. So for you to find your point of inflection, all you need to do is x equals your minimum plus your maximum all over 2. That's your midpoint formula. If you want to find the midpoint of something, you add the two endpoints divided by 2. So let us go and see what are the x values of our minimum and our maximum. Those were the values of A and B that we previously calculated. Let us see, where did we calculate it? Calculate the coordinates of A and B, question 8.2. Here is question 8.2. So here we can see that our values of A and B, our minimum and our maximum, are 2, 1, 2, and 0, or rather negative 0.79. So for us to calculate our point of inflection using the second method, all we need to do is substitute into this formula or calculate the midpoint. So 2, 1, 2 plus negative 0.79 all over 2. And if you put that into your calculator, you'll end up with 0.67. And we know 0.67 is just 2 over 3. So that is our value of K. That is the second method that you can use. So I'll repeat both once more. If you are finding your point of inflection and you have an equation, all you need to do is derive twice, equate to 0, solve for x. That is it. If you do not have an equation, but you have the x values of your stationary points, because sometimes they can tell you the equation is unknown, but they can give you the x values of your stationary points on your graph. All you need to do is add up the two x values of your stationary points and then divide it by 2, because your point of inflection is the midpoint of your stationary points. So that is question 8.4.